Welcome back, learner. Ready for another deep dive? Today, we're going to look at all the cool stuff that happened in AI on April 10th, 2025. You want to get to those key insights, those aha moments, without having to wade through a ton of information.
You got it.
So we're going to cut straight to the chase and break down the biggest AI news of that day, starting with, well, how about how AI agents might talk to each other?
Sounds good.
One of the things that stood out to me was this announcement from Google and DeepMind, about a new protocol. They're calling it agent-to-agent, or A2A. And this came out at the same time they announced full support for MCP. It seems like A2A is meant to work alongside MCP to kind of fill in some gaps in how AI agents interact.
Yeah.
So what's the main idea behind A2A?
Well, at its heart, A2A aims to offer this structured and standardized way for AI agents to team up and exchange information. The A2A spec lays out some key parts. First, there's this thing called the agent card, kind of like a digital ID, giving you the rundown on an agent's skills and who they are. Then you have the concept of a task. This acts as a dedicated channel for communication where agents can swap messages. Ultimately, they produce an artifact, which is basically the outcome of their collaboration.
So it's like setting up a formal framework for AI teamwork.
Right, exactly.
And it's not just about the tech stuff, right? They've also included these recommendations for enterprise-level things, like authentication, making sure the agents are really who they say they are, and also observability, so we can track and understand these interactions.
Right. Security is crucial, especially when it comes to real-time info exchange, like streaming or push notifications. The A2A spec actually offers security advice for these features.
That makes sense.
Yeah.
But now I'm thinking, isn't Anthropic's Model Context Protocol, or MCP, already doing something similar?
That's a valid point.
It does make you wonder about, potential overlap or even competition between them.
Right.
Especially if an agent's using MCP to connect, as a client or server.
That's true. However, Google says that A2A is more like a complement to MCP. They can work together.
Okay, so they're not trying to replace it.
Yeah.
But here's a thought. Some people are saying that Google might be playing a bigger game, right? They're thinking Google wants to make these agent communication tools, a common resource, readily available. And their ultimate goal, dominate the AI agent scene. What do you think about that?
It's an interesting idea for sure. If you think about it, in terms of cloud infrastructure and AI services, if Google can provide a communication layer that's both robust and widely used, it could make it a lot easier for developers to build agents on their platform, regardless of what AI models they're actually using.
So it becomes the go-to place for building agents.
Potentially. It raises a question, though, about the future architecture of AI applications. Will we see everyone sort of coalescing around a few major communication standards?
Yeah.
Or will things stay kind of diverse and fragmented,
That's a good question.
Oh.
Okay, let's shift gears now and talk about some exciting things happening in open source AI models.
Okay.
First up is DeepCoder 14b, which was released by UC Berkeley.
I saw that.
This is a coding model, and it can apparently hold its own against some of OpenAI's heavy hitters, like O3 Mini and O1, on these coding benchmarks.
Right.
And here's the kicker. It's completely open source.
The big deal.
Why is that so significant, an open source model performing at this level?
It really signals a shift, I think. You have this open source model that's achievable with what is, relatively speaking, a small budget. They estimate the training cost at around $26,880.
Wow.
And it's competing with these proprietary models. It could democratize access to advanced AI capabilities and maybe even shift power away from closed systems.
So it's leveling the playing field.
Potentially. And this DeepCoder 14b, it was trained using reinforcement learning.
Oh, that's where the AI learns by trial and error?
Right.
Right.
Exactly. Based on feedback. They used a base model called DeepSeek R1 Distilled Qwen 14b, and they trained it with 24,000 coding problems.
Okay. So pretty complex stuff.
Yeah. And they managed to keep the cost relatively low. They used 32 H100 GPUs over about 2.5 weeks.
That gives you an idea of the scale and cost involved. And it's released under the MIT license.
Right.
Which means it's very open in terms of how it can be used and modified.
A lot of freedom there.
And it's compatible with VLLM, TGI, and transformers.
Yeah.
These toolkits that help developers work with and deploy these models.
Right.
And they even released a smaller version with 1.5 billion parameters.
I did see that.
The reaction to DeepCoder in the open source community has been, well, pretty enthusiastic. People are excited to have this fully open 14 billion parameter coding model that performs so well, there's even talk about potential larger versions, maybe a 32 billion parameter model,
Yeah.
or one built on the Llama 4 architecture.
Interesting.
Really shows the collaborative spirit of the open source AI world. People have already noticed improvements in things like GRPO, which is grouped relative positional encoding.
Yeah.
That's a technique to help the model understand like the structure of code.
Right.
And they've also made the training process more efficient.
That's great.
Now, there's been some discussion about, small differences in benchmark results across different tests.
Sure.
But the consensus is that this is a big step forward for open coding models of this size. I even saw that someone took this and ran with it and released a fine-tuned version called DeepCoder 14b Preview.
Amazing how quickly things move.
It's really impressive how quickly people are building on each other's work in open source. I think this raises a question for you, learner. With these capable open coding models becoming more readily available, how might this reshape software development? And who gets access to these powerful tools? It's something to consider. Now, moving from making code to making images, the AI Daily News also highlighted HiDream I1 Dev as the new top dog in open weights image generation. It's supposed to be even better than FLUX 1.1.
It's quite a feat.
This one's a biggie, 17 billion parameters, and it comes in 3 flavors, full, dev, and fast.
And what makes HiDream I1 Dev particularly cool is that they released a quantized version, HiDream I1 NF4.
Okay.
Think of it like a compressed version,
Yeah.
It's smaller and doesn't need as much memory. About 15 or 16 gigabits of VRAM, which is video RAM. That's way less than the full model, which needs over 40 gigabits.
So it's much more accessible now.
Exactly. This means people without the latest graphics cards can still use it. Plus, it's super easy to install. You can do it directly with pip.
That ease of access is huge, isn't it? When you lower the hardware barrier, it opens up these powerful tools for more people to experiment and get creative with. I even saw some funny comments online about the VRAM thing. Some sources said 15 GB, others 16 GB.
Right.
But hey, it's a small detail in the grand scheme of things.
Right.
And people are already asking for even lower VRAM versions, like 12 GB. And they want seamless integration with Comfy UI, which is a popular platform for building generative AI workflows.
I've heard of that.
So, people really want to make these models work for them in their existing setups.
Makes sense.
And speaking of open sourcing leading models, the news also highlighted Uno.
Oh, yes.
This one's built on the Flux architecture. And apparently, it's now leading the pack in multi-image customization.
That's impressive.
It can do some really interesting things like subject-driven operations and virtual try-ons.
Wow.
Yeah, so Uno is all about personalized and artistic transformations.
I see.
It can do things like, generate images with one or more specific subjects. You can also preserve identity across different outputs, which is pretty neat. And it can do virtual try-on applications and even stylized generation. And of course, they've shared the code on GitHub, so anyone can play around with it and contribute to its development.
That's awesome.
The reaction to Uno, though, has been a bit mixed compared to HiDream. Some folks are skeptical, saying it has similarities to things like prompt injection, where some cleverly crafted text can lead to unexpected outputs. And they also pointed at issues with face accuracy and the way it renders environments.
I see.
On the flip side, others said they got better results using objects instead of people.
Interesting.
They even found that if you intentionally mismatch the reference image with the text prompt, you can get some unexpected results.
Wow.
But again, everyone wants to know about the VRAM requirements and how well it works with Comfy UI.
Of course.
Shows you, the challenges and different experiences people are having with these rapidly evolving models.
It does highlight the complexities of achieving reliable performance in different generative AI applications.
Yeah.
And the crucial role of community feedback in identifying what works and what doesn't.
Exactly. All right, now let's talk about the hardware that makes all this AI magic happen.
Okay.
Google announced their 7th generation tensor processing unit, codename Ironwood.
I saw that.
And they're clearly going head-to-head with NVIDIA's Blackwell B200 GPUs.
Yeah.
And the specs, impressive. 4,614 teraflops of compute per chip using FP8. They also have 192 gigabytes of high bandwidth memory and super fast memory and inter-chip communication.
It's powerful stuff.
It is. The scale of Ironwood is remarkable. A full pod with 9,216 chips. Google calls this a 24x El Capitan configuration, delivers a whopping 42.5 exaflops. And Google's saying that Ironwood is designed for both training those huge AI models and for running them efficiently in inference, which they're calling thinking models.
Interesting.
So it's ready for the most demanding AI tasks. Of course, everyone started comparing it to NVIDIA's hardware. One user pointed out that Google has a big advantage because they control their entire infrastructure, from design to manufacturing. They don't have to rely on buying hardware like some other companies, like OpenAI.
Right.
Someone else noted that Ironwood is supposedly twice as fast as an H100 for FP8 inference.
Really?
Yeah, and seems to be on par with the B200. So very competitive. What do you think? What happens when Google enters the high-end TPU market this aggressively?
Well, it could really shake things up.
Yeah,
Google making their own high-performance AI hardware. Not only does it secure their internal needs, but it could also make a big splash in the cloud computing world. They're offering a strong alternative to GPUs. They might attract researchers and companies looking for specialized AI infrastructure.
and they're not holding back on resources.
Mm.
Ironwood uses liquid cooling, and a full pod consumes nearly 10 megawatts of power.
It's a serious investment.
Sticking with Google, they also introduced the Google Agent Development Kit, or ADK. It's an open-source Python toolkit for building AI agents. The code's on GitHub, and there's also documentation available. It seems they're giving developers the basic tools to start creating these autonomous AI entities.
That makes sense.
Right. They're really focused on building up a community around AI agent development.
It seems that way.
Now, for our startup listeners, Perplexity AI launched something called Perplexity for Startups. They're offering eligible startups $5,000 in credits for their Perplexity API,
Wow.
plus 6 months of their Enterprise Pro plan for their whole team.
That's a good deal.
To qualify, a startup needs to have raised less than $20 million, be under 5 years old, and be part of one of Perplexity's partner organizations.
Okay.
They're also launching a bigger partner program.
Interesting.
And their CEO, Aravind, did an AMA on Reddit. So it seems they're really trying to connect with developers and get feedback.
Smart move.
It is, especially with all these new AI models and platforms popping up.
Yeah.
Giving startups access to their API could lead to some pretty cool new applications.
Absolutely.
So learner, we've covered a lot from just one day in AI. From Google's vision of connected AI agents with A2A to the open source progress in coding with DeepCoder and image generation with HiDream and UNO-A, things are moving fast.
That's for sure.
And with Google's powerful new Ironwood TPUs and initiatives like Perplexity for Startups, the infrastructure and accessibility of AI are also changing rapidly. But here's where it gets really interesting. How do all these developments interact with each other? How will standardized agent communication protocols like A2A and MCP shape the applications built using powerful open source models like DeepCoder, especially running on specialized hardware like Ironwood? And what impact will the increasing availability of advanced AI tools and infrastructure, like with Perplexity for Startups, have on the rate of innovation? What kinds of companies will be able to enter the AI space?
Good questions.
This brings us to a key question for you to ponder, learner. As these fundamental building blocks of AI become more sophisticated and interconnected, what brand new possibilities might open up in your field? It's a huge, ever-changing landscape. And we hope this deep dive gave you some valuable insights and maybe even sparked a few of those aha moments. Keep those questions coming, and we'll keep exploring the most important happenings in the world of AI.
We will.
Until next time, learner.
See you then.